Hello everyone. Now we're going to study ozonolysis. It's an important and interesting reaction. Hydrolysis, you know what it is. Hydrolysis means breaking of a compound by water in water. Photolysis, you understand, photolysis is breaking up of a substance, of a reagent, of a substrate, of a molecule in presence of light. Photo means light, lysis means to break. Photolysis means breaking in presence of light, hydrolysis means breaking in presence of water. So by extension, ozonolysis would mean breaking in presence of ozone or breaking by ozone. That's what happens in the reaction. We have a alkene and we take ozone as a reagent in this reaction. We also take zinc. When we take zinc, we call it reductive ozonolysis. When we don't take zinc, that is oxidative ozonolysis. And why it is so, when we will see the mechanism, it will become clear. So, but for the time being, we generally take zinc, and this kind of ozonolysis is called reductive ozonolysis. When we do this, what happens? This alkene breaks from here. This carbon-carbon double bond is broken, and each carbon which was previously participating in formation of carbon-carbon double bond, that forms carbon-oxygen double bond. That means these two carbon which were involved in making carbon-carbon double bond would now form individual carbon-oxygen double bond. This carbon is now making carbon-oxygen double bond. This carbon will make another carbon-oxygen double bond. So here we have two oxygen. These two are coming from ozone. Both the carbon forms carbon-oxygen double bond. Rest of the bonds will remain as it is. Fine. And one of the oxygen will go to form zinc oxide, ZNO. Here. Fine. If we don't add zinc, this oxygen would have oxidized one of the aldehyde that has been formed as a product of ozonolysis. So since there is no oxidation of aldehyde, so this is reductive ozonolysis. When we see the mechanism, it will become more clear. But for the time being, this is a reactant in ozonolysis reaction. We take a alkene. This is a reagent. We take ozone and zinc to do reductive ozonolysis, and this is what we get. We get carbonyl compound. Now suppose if there would have been R, not hydrogen, then this would have been ketone. Fine. But in general, if we take alkene like this, we'll get this kind of product. Depending upon what the alkene is, either we'll get aldehyde or we'll get ketone. But nevertheless, we'll get carbonyl compound, and this is the method. This is the way how you would get the product from the given alkene. You will break the alkene into two halves, and the carbon that was forming pi bond, double bond with another carbon, will now form a double bond with oxygen. And that's how you will break, and that's how you will do the lysis of this alkene. And this reaction would be called ozonolysis. Now before we see the mechanism how this happens, it is more important to learn to write the product given a substrate, given alkene as a substrate. Now we will practice certain problems in order to how we would write the product from a given alkene. Now once we get handy with it, then we will see the mechanism. Mechanism as such is not important, so I'm delaying looking at the mechanism. What's more important is how to write the product from the given alkene. So let's do that. Let's start with simple rudimentary substrate, and then we'll move on and reach to the pinnacle of this topic. Let's start with ethene. Suppose I have ethene and I took ozone and zinc. I carried out reductive ozonolysis. Now the method of writing the product is simple, as I have told you before. You will break the alkene from here, and the carbon which is making double bond with carbon will now make a double bond with oxygen. So you will break it into two halves, and each carbon will be forming C double bond O. So you will get this carbon forming C double bond O, and this carbon also forming C double bond O. So you will get methanol. 2 methanol, this ethene will break into 2, and you will get methanol from both the sides, because it's a symmetrical alkene. And whether if you want, you can write ZNO. If you don't want, you don't write, doesn't matter. But you have to show the major organic products. Suppose we have propene. Then propene will also follow the same procedure, and you have to start doing it now on paper and be handy with it. You will again do the same thing. You just have to break the pi bond and divide this alkene into 2 halves on both sides of that pi bond, giving a double bond with oxygen to each of the carbon that was making a double bond with carbon in the pi bond. That's what you have to do. So on this side you will have 2 carbon, and this carbon will participate in formation of double bond with oxygen. So from this side you are going to get ethanol. I'm not showing double bond. If you want, you can show it like this. So this ethanol is coming from left hand side. From right hand side there's 1 carbon, and that carbon will go in formation of C double bond O. So that will give you methanol. So this will be the corresponding ozonolysis product of propene. So let's see another alkene. Suppose we have isobutene, and we are carrying out reductive ozonolysis with it. Now from now you should giving out the answer to me before I write the answer. You'll do the same thing, exactly the same thing. From left hand side you're going to get, suppose you add C double bond O to this carbon, what would you have? You'll get propanone, more commonly called as acetone. Acetone is a very common name, and if you get this compound in exam, they will write acetone and not propanone. Acetone is a very common name. And from right hand side you'll get ethanol. Fine. So this is how you will proceed writing the product of ozonolysis. This is more important to know the mechanism. So you should be very handy with it. Now I'm giving certain substrates. Now I'll not be doing it for you. You have to do them on your own. So the question is, write the ozonolysis product for the following.